Welcome all my dear student of FYBSc class. Today we are going to see the second topic of fourth chapter, surface tension and elasticity, that is properties of matter, and in this chapter the second topic is elasticity. Generally all the bodies undergoes a certain changes in their physical dimensions. That means what? Deformation takes place when we apply the force on the body. When external force is applied on it, body get deformed and have a tendency to regain or to gain back their original state after removal of deforming forces. And thus elasticity can be defined as the tendency of a body by virtue of which it suffers a change in shape and size under the action of deforming forces and regain its original state or removal of deforming forces is called as elasticity. Very simple definition. Elasticity म्हणजे काय की ही मॅटरची टेंडन्सी आहे की ज्या टेंडन्सीनुसार ज्यावेळेस आपण एखाद्या बॉडीवर एक्सटर्नल फोर्स अप्लाय करतो तर त्या बॉडीचा शेप अँड साईज काय होते बदलते आणि ज्यावेळेस आपण तो फोर्स रिमूव्ह करतो त्यावेळेस ती बॉडी पुन्हा तिच्या ओरिजिनल स्टेटला जाते, यालाच आपण म्हणतो इलास्टिसिटी. ओके, द बॉडी विच possesses this property are called elastic bodies. For example, rubber. But this is my experience. When I ask to the students, give number of examples, then every student gives only the example of elasticity is rubber. But if I say that steel is elastic, wood is elastic, yes, of course, when we consider a particular form of that matter, if we consider a spring or hacksaw blade of stainless steel, then obviously it shows the tendency or it shows the property of elasticity. That means what? When we apply a force on the spring, that means if we compress the spring or elongate the spring and after removal of the spring force, the spring regain its original shape and size. This is nothing but elasticity. Okay. Now the bodies or body which can recover their original state completely and immediately after the deforming forces are removed, then such bodies are called perfectly elastic bodies. What I say? The body which can recover their original state completely and immediately after the deforming forces are removed, then these bodies are called perfectly elastic bodies. For example, quartz fiber. Okay, and whereas other bodies not showing any tendency to recover their original state or original shape and size, these bodies are called plastic bodies. For example, plasticine or lead are the examples of plastic bodies. Okay. Now here we are going to see the stress and strain. I told you at the beginning of this chapter that means elasticity, most of the part of this chapter elasticity or most of the part of this topic elasticity is already covered in 12th science. And here there is only extensive part, but we are again going to repeat the definition of elasticity, the examples of elasticity, the definition of plasticity, perfectly elastic body, plastic body along with the example. And now stress and strain are already covered or you already studied this point in 12th science. Though we are again going to repeat. Okay, first of all, stress. What is stress? Stress. When a force acts upon a body, what I say, when a force acts upon a body so that to change its to change its size and shape. That means what? Internal resistive or internal restoring forces or force is developed in the body. ज्या वेळेस आपण एखाद्या बॉडीवर फोर्स अप्लाय करतो त्यावेळेस त्याच वेळेला त्या बॉडीच्या आतमध्ये सुद्धा एक फोर्स तयार होतो आणि त्या फोर्सला आपण म्हणतो internal restoring force or internal resistive force. And hence here I say that when a force acts upon a body so as to change its shape and size, internal resistive or internal restoring force is developed in the body. So long as external force is greater than internal restoring force, the body undergoes a change in its shape and size. जोपर्यंत एक्सटर्नल फोर्स हा इंटरनल रिस्टोरिंग फोर्स पेक्षा जास्त असेल तोपर्यंत त्या बॉडीचे शेप अँड साइज कंटिन्युअसली काय जाणार चेंज होत जाणार. ओके, व्हॉट आय से, सो लॉन्ग एज एक्सटर्नल फोर्स इज ग्रेटर दॅन इंटरनल रिस्टोरिंग फोर्स द बॉडी अंडरगोज ए चेंज इन इट्स साइज अँड शेप कंटिन्युअसली. व्हेन एक्सटर्नल फोर्स or external forces are equal to internal restoring forces, the body will not show any further change in its size and shape. And from this we can define the stress. The stress can be defined as it is the ratio of internal restoring force upon area. But we can't measure the internal restoring force, as internal restoring force cannot be measured directly, but it is equal to applied force. What I say, internal restoring force cannot be measured directly, but it is equal to the applied force, and hence the internal restoring force per unit area of the body is called stress. This is the proper definition. Okay, the internal restoring force per unit area of the body is called stress, and that is, we can say that as we can't measure the internal force, here we can write stress is equal to applied force upon area. Suppose F is the force, then stress is equal to F upon A, where is the area. In this way we can study or we can define the elasticity, we can define the stress. I am again going to repeat the definition of stress. The internal restoring force per unit area of the body is called stress, but we can't measure the internal restoring force, and hence we can define the same definition as stress is nothing but it is the ratio of, or stress is nothing but applied force per unit area. If F is the force and A is the area, then we can write stress is equal to F upon E. Now the units of stress. What is the unit of stress? We know that force, SI unit. What is the SI unit of stress? What is the SI unit of force? Newton. Okay, Newton upon meter square or Newton per meter square. Because area is nothing but length into breadth, and length into breadth or length into length, hence meter square, and force is C.J.S. unit. Dynes C.J.S. unit, centimeter gram second, is nothing but dyne per centimeter square. Very simple. Okay. Now dimension. What are the dimension of stress? Okay, see here. Again from this definition, we are going to obtain the dimension. We know that stress is equal to force upon area. Force is nothing but mass into acceleration upon area is nothing but length into length. Okay. Now, what are the dimension of mass? M raised to 1, L raised to 0 and T raised to 0. What are the acceleration? What are the dimension of acceleration? Acceleration nothing but length upon second square, meter per second square. Okay. Therefore, M raised to 0, L raised to 1 and T raised to minus 2. And again dimension of this length is nothing but M raised to 0, L raised to 2 and T raised to 0. When we solve this, then we get M raised to 1, L raised to 1 minus 2 and T raised to minus 2, or simply M raised to 1, L raised to minus 1 and T raised to minus 2. Okay, these are the dimensions of surface tension. Very interesting one. If we study or if we obtain the dimension of pressure, then these dimension of stress and dimension of pressure are one and the same, and hence the unit and dimension of stress is similar to pressure. Remember that unit and dimension of stress is similar to that of dimension of and unit of pressure. Okay. Now, the second quantity, strain. Second, what is strain? When strain is produced, when stress is acted, at that time strain is produced. Or in another language or in another word, we can say that when a body is acted upon by deforming force. When a body is acted upon by a deforming force, it undergoes a change in its size and shape, size or shape or both. Thus, strain can be defined as the change in dimension per unit original dimension of a given body when acted upon by a force or torque. Or in simple way, we can say that strain is nothing but it is a ratio of change in dimension per unit original dimension. What I say? It is a ratio. Change in dimension per unit original dimensions. Okay, have you got it? Suppose if we consider a wire of length L and one end of the wire is fixed to rigid support and stretching force is applied to free end of the wire. What happens? It is observed that the length of the wire goes on decreasing. Suppose L is the length of wire and small is the increase in length. Then change in length per unit original length, change in dimension per unit original dimension. These are nothing but strain, and this strain is regarding to length or related to length, and hence this is called longitudinal strain. Okay. Now, what will be the unit and dimension of strain? See here, length is measured in centimeter, change in length is measured in centimeter, and original length of the wire is also measured in centimeter. Centimeter get cancelled. Or if we measure it in SI unit, that is meter per meter, get cancelled, and hence the strain is a pure ratio and it is unitless and dimensionless quantity. Okay. Now, another point, we are going to say another point, Hooke's law. This is also studied by you in 12th science. What is Hooke's law? Robert Hooke Robert Hooke in 1679. Introduced this law first time, and this is fundamental law. What I say, Hooke's law is a fundamental law of elasticity and was first introduced by Robert Hooke. And this law is very simple. What is Hooke's law? See here, stress is directly proportional to strain within elastic limit. एकच वाक्यात डेफिनेशन आहे. स्ट्रेस इज डायरेक्टली प्रोपोर्शनल टू स्ट्रेन within elastic limit. Okay, hence we can say that this, or stress upon strain is equal to what? Constant. कसं मिळाले? From this you can write stress is equal to K into strain, where K or constant into strain, where C is the constant of proportionality, and from this we can obtain this derivation, stress upon strain is equal to constant. Okay, this constant is called modulus of elasticity. Modulus of elasticity, or the coefficient of elasticity. Modulus of elasticity or coefficient of elasticity, and it is the property of material of the body. Here we studied that strain has no unit and no dimension, and stress having the unit Newton per meter square, SI unit, and dynes per centimeter square, CGS unit, and hence the modulus of elasticity or coefficient of elasticity has the same unit and dimension that of stress. Modulus of elasticity चे जे युनिट अँड डायमेन्शन असेल ते स्ट्रेस सारखेच असतील, कारण जो जरी तो रेशियो असेल पण स्ट्रेन ही युनिटलेस अँड डायमेन्शनलेस क्वांटिटी आहे. ओके, नाउ हियर वी आर गोइंग टू सी modulus of elasticity in details. Okay, now let me know what will be the definition of modulus of elasticity. We already seen here, modulus of elasticity is the ratio of stress upon strain. Okay, Hooke's law is obeyed if deformation is small. Remember that very important point, this. Hooke's law is obeyed if deformation is small. If the body is stretched beyond the elastic limit, the stress is not proportional to strain, and Hooke's law is not obeyed. That means what? Suppose the stress along y-axis and strain along x-axis. As strain is increased, stress is also increased. Stress is directly proportional to strain, but suppose this is the elastic limit. Elastic limit. Up to elastic limit, stress is directly proportional to strain, and after elastic limit, permanent deformation in the body is formed. Okay. Sometimes this limit is also called a proportional limit. Hooke's law holds good up to maximum stress called proportional limit. What is proportional limit? Very simple. There is not a large difference between elastic limit and proportional limit, but you should know the perfect difference between them. proportional limit, Hooke's law holds good up to maximum stress called proportional limit, and elastic limit when the stress is less than the elastic limit, then after removal of stress the body will return to its original state, that is original shape and size. If the elastic limit is exceed, what happens? The body remains permanently deformed, and this is nothing but elastic limit. Okay. Then ultimate strength. What is the ultimate strength? If the ultimate strength is exceed or surpass, the body fractures. Ultimate limit म्हणजे काय की जर समजा अल्टिमेट स्ट्रेंथ असते मटेरियलला, ती जर एक्सीड झाली, आपण खूप स्ट्रेच वायर घेतली किंवा स्प्रिंग घेतली तरी खूप ताणली तर काय होणार आहे, तिथं फ्रॅक्चर्स पाहायला मिळतील आपल्याला. आणि म्हणून द अल्टिमेट strength is exceed, the body fractures, and the ultimate strength can be different for tensile and compressive stresses. Compressive stresses म्हणजे काय? सर्व प्रकारचे स्ट्रेसेस, सर्व समाविक स्ट्रेसेस, त्यांना आपण म्हणतो compressive stress. Okay. Now along with this we have to also know two more quantities regarding material. First one, ductile मटेरियल, ज्याच्यामध्ये तंतू असतात. म्हणजे स्टील घेतलं आपण, त्याचं आपण काय करू शकतो, वायरमध्ये त्याचं रूपांतर करू शकतो, त्याच्यापासून वायर्स तयार करू शकतो आपण. वायर्स म्हणजे तंतू. हे डक्टाईल मटेरियल कंटिन्युअस टू स्ट्रेच बियॉन्ड अल्टिमेट स्ट्रेंथ विदाउट ब्रेकिंग अँड स्ट्रेस डिक्रीजेस फ्रॉम अल्टिमेट strength. Okay. There is one more material, brittle. Brittle means in Marathi ठिसूळ. A brittle material has the ultimate strength and the breaking point close together. Okay. Now after this we are going to see the elastic moduli. Moduli, this is the plural form of modulus. There are three types of stresses: longitudinal stress, volume stress, and shearing stress. Also there are three types of strains: longitudinal or tensile or linear. There are three terms. These are the synonymous terms: tensile or longitudinal or linear. Okay, there are three types of stresses: tensile or longitudinal or linear stress. Then second one is volume stress, and third one is shearing stress. Just like this, there are three types of strain: tensile or longitudinal or linear strain. Second one is volume strain, and third one is shearing strain. Now we are going to see in details. First, like this, there are three types of modules. There are three types of moduli, or there are three modulus. One of them is Young's modulus, denoted by Y or E. Second one is bulk modulus, denoted by small k. And third one is modulus of rigidity, and denoted by eta. Okay. Now we are going to see the Young's modulus. What is Young's modulus? Young's modulus. See here, Young's modulus is defined as, very simple definition of Young's modulus. Young's modulus is defined as the ratio of tensile or longitudinal or linear stress upon tensile or longitudinal or linear strain. Okay. This is the Young's modulus. And hence, in short, in a single sentence, we can say that we can define the Young's modulus as the ratio of longitudinal stress to longitudinal strain, or tensile stress to tensile strain, or linear stress to linear strain. Okay. And notation for this is a letter Y or E. See here, when deforming force is applied to the body only along the particular direction, the change in length per unit original length in that direction is called longitudinal strain. What I say? When a deforming force, that is stretching force, is applied on this wire along a particular direction, that is along a length, the change in length per unit original length is nothing but longitudinal strain, and force per unit area of cross section of the wire is nothing but stress, and hence longitudinal Young modulus is nothing but longitudinal stress upon strain, or tensile stress upon strain, or linear stress upon strain. See here, if the wire of length L and area of cross section A is stretched by a force F, capital F, what will happen? The wire increases by small l. Then Young's modulus is nothing but, according to this definition, Y is equal to force upon area upon small l upon capital L. This is stress and this is strain. Longitudinal stress upon longitudinal strain. Or from this we can write F L upon A L. When deforming force is applied to the body only along particular direction, the change in length per unit length, I already told you. Okay. Now the units and dimension of Young's modulus. Here again, strain has no unit and no dimension. Hence, the Young's modulus have the units and dimension similar to that of stress. That is, SI unit is Newton per meter square and CS unit is Din per centimeter square, and dimension is m raised to 1, L raised to minus 1 and T raised to minus 2. Remember that only solid possesses Young's modulus and liquid and gases does not have Young's modulus. Why? Because they do not possess length. Liquid and gases do not have their own length, and that's why they do not possess, or they do not have the Young's modulus. They do not possess Young's modulus. Okay. Now remaining two moduli, that is bulk modulus and modulus of rigidity, and work done during longitudinal strain will be studied in the next lecture. Till then, we shall stop here. Have a good day.